Yeah, good morning, my connects, my friends, my peers, my colleagues, and last but not the least, my students. Today, happy Holi to all of you. One message from my side: be safe, play safe, and keep your environment clean. Okay, so today, actually, I'm going to talk about oxidation and reduction in terms of electronic transfer. Fine. And yesterday actually I was teaching the students, and the situation which actually was created over there, it was quite perplexed. Fine. And the student also got confused at last. He understood the concept, but like, it was a very time taking process. So that's why, in short, I'm going to tell you that by means of my oratory, just by means of my oratory, I'm just going to give you the concept of oxidation and reduction. It is very easy, student. It is very, very easy. The first thing which you need to know is electrolysis, its definition, electrolyte, then the procedure involved in electrolysis. Okay, so now let us talk about electrolysis. What is electrolysis? Now, when you are writing the definition, I already told you that you need to focus upon the keyword. Now, electrolysis is defined as the process, or it is a procedure where the decomposition of electrolyte takes place in an aqueous solution or in a molten state. Electrolysis is a process where the decomposition of an electrolyte takes place. That means decomposition is one keyword, electrolyte is another keyword, two keywords, in an aqueous solution, three keywords, or in a molten state, four keywords are there. If you miss one, then you are going to lose an iota of mark. Fine. Now, what are electrolytes? Now, electrolytes actually are defined as cations and anions. Okay, electrolytes are defined, or it is bifurcated to cations and anions, which are synonymous with freely charged particles. Because it is defined as freely charged particles, electrolyte electrolyte conducts electricity. Now you can tell me that, sir, how electrolyte conducts electricity? Because electrolyte contains ions. Okay, electrolyte contains ions, and ions are freely charged particles. Okay, ions are freely charged particles which conducts electricity. Now these three keywords you need to remember: freely charged particles are defined as ions. Electrolyte contains ions. Electrolyte contains ions. So as a whole, electrolyte is a good conductor of electricity. Ion is also a good conductor of electricity. Now let us take an example of a common salt. Now, what is the formula of common salt? NaCl. Now we all know that the electronic configuration of sodium is 281, and the atomic number of sodium is 11, whereas the atomic number of chlorine is 17. Fine. So if I go by Bose and Bury distribution of an electron, then I have to follow 2n square, where the n would be representing the number of shells. Fine. So in the first shell, sodium is going to have 2 electrons, because 2 into 1 square equal to 2, right? 2 into 1 square equal to 2. Then 2 into 2 square equal to 8. So sodium is having 11 electrons, 10 gone. Now in their outermost shell, sodium is going to have 1 electron. Now let's come to chlorine. Chlorine is, the atomic number of chlorine is 17. Now if I consider Bohr and Bury scheme of distribution of electron, then in the first shell it is going to have 2 electrons. Now in the second shell it is going to have 8 electrons. Then out of 17, 10 gone. How many remains? 7 remains. So 7 electrons chlorine would be having in the outermost shell, or which is known as valence shell. In ICSE or in IGCSE or in CIE is very much important to say it or to name it as valence shell. VALENCE. You may write it down, VALENCE, valence shell. And it is a lecture method. I told you that by my oratory, I'm going to clear your concept. So now the thing is that what is an atomic number? Most of the students, they do the mistake. Now atomic number is defined not as the number of electrons. Electron revolves around the nucleus, but atomic number actually is defined as the number of protons. It is not defined as the number of electrons. Now what happens? The number of protons are equal to the number of electrons. Are you getting my point? So if 11 is the atomic number of sodium, then 11 protons are present inside the nucleus, which is responsible for the mass of an atom. Now the number of protons are equal to the number of electrons. That's why the number of electrons in sodium is 11. And the same concept goes for chlorine. Got it? I hope you have understood. Now the second point, metals. Sodium is a metal, whereas chlorine is a non-metal. Fine. I'm just explain you in a simplistic fashion. Okay. So now sodium is having 1 electron in their outermost shell, and all the elements, 118 elements, they are trying to attain 8 electrons in their outermost shell or in their valence shell. Means they want to satiate the noble octet configuration. The spelling of octet is OCTET. Okay. So now sodium actually is a metal, whereas chlorine is a non-metal. Now we all know, it's very basic, that metals are known as an electron donor. So sodium is going to donate 1 electron and it is going to be positively charged. So Na is going to donate 1 electron and it is automatically going to get converted to Na plus ion, because it is releasing electron. And when it is releasing electron, the flow of electron is taking place, and whenever the flow of electron is taking place, electricity will come into the context. Whenever, what is electricity? Electricity is nothing but a flow of electrons. So whenever in aqueous solution or in molten state, if sodium ejects 1 electron from its outermost shell, it becomes positively charged ion, whereas chlorine is gaining electron. Okay, chlorine is gaining electron from sodium because in order to satiate stable octet configuration or noble gas configuration, so it is going to get converted to negatively charged ion, because it is actually absorbing electron which is negatively charged. So when it is absorbing negatively charged particle, of course it is going to get transformed to an anion which is negatively charged, right? If I absorb any negative thing, then I am going to have negativity. If I absorb anything positive, then I am going to gain positivity. It's very basic. So now what happens? Sodium is getting transformed to a cation after releasing 1 electron, whereas after the intake of an electron, chlorine is getting formed to an anion. Okay. Now in electrolysis what happens? Cathode is present. At the same point of time, anode is present. Now cathode is actually negatively charged thing, whereas anode is positively charged thing. Cathode itself is negatively charged, which attracts cations, which is positively charged. Fine. So what happens over there? Na reacts with negatively charged cathode to form a stable sodium ion. So here what is happening? Here actually sodium is gaining an electron if I consider the reaction in cathode. How? Na plus 1 electron, because cathode is negatively charged particle. Cathode itself is negatively charged. It's very much unprofessional of me to say particle, but cathode itself is a rod which is negatively charged. Fine. So what is happening? What is the reaction happening in cathode? Na1 plus 1 electron. So give the arrow and it is forming sodium. Now what is the reaction which is taking place at anode? Already it is Cl1 minus. Now Cl1 minus already it's there. Okay. Now anode is a positively charged thing which allures anion. Now anion is negatively charged particles. Anion is negatively charged particles. So what will happen? Cl, I will give Cl, then arrow, I will give Cl1 minus, because already it has taken 1 electron from sodium in order to gain the stable octet configuration. So Cl1 minus, I will give arrow and I will write Cl plus 1 electron. This would be the reaction. I repeat, in cathode the reaction would be Na 1 plus 1 electron, it is going to give Na, whereas Cl, I will give the arrow Cl1 minus, Cl1 minus, then I will give the arrow and I will write Cl plus 1 electron. So now we have to see where the gaining of electron takes place, where the losing of electron takes place. This is all about oxidation and reduction in terms of electronic transfer. Now the gain of electron, where the gain is taking place in cathode. So now the gaining of electron is known as reduction. Gaining, seriously, it is gaining 1 electron, right? Sodium is gaining 1 electron. When it comes to the reaction which is taking place at cathode, it is gaining 1 electron. So the reduction is taking place at cathode. Fine. Whereas now chlorine 1 minus gives the arrow and write chlorine plus 1 electron. So chlorine is losing 1 electron. Chlorine is losing 1 electron at the anode, so oxidation is taking place over there. It's very simple. Fine. So what is reduction? Where the gaining of electron is taking place. Gaining of electron means reduction. Losing of electron means oxidation. Now reduction takes place at cathode. Key point. Reduction takes place at cathode, whereas oxidation takes place at anode. Understood? This is all about oxidation and reduction by means of lecture method or by means of an oratory skill. Now let me tell you, now if the teacher follows this method, the students, those who are lying in mediocrity, or the students, those who are really really serious, careful and brilliant, it is for them. But it is not going to get applied for those students, those who are slow learners, those who cannot concentrate in the class, you know so that's why board work, audio visual learning, peer learning, concept based learning, I have given you the concept based learning, fine, but whatever I have described by lecture method. Now lecture method was quite prevalent in 90s. Now slowly it is getting obsolete, particularly in science. Now why, you know I could give the lecture method by my oratory? Because I'm habituated to it, fine. But the teachers, and I feel that it has a defined approach. I can't say that reduction means losing of electron. I can't say that. I have to say that reduction defines gaining of electron which is taking place at cathode. Again I repeat, reduction means gaining of electrons, whereas oxidation means losing of electrons, right? So it is a very defined approach. That's why, by my oratory I could make you understand, or I could make you understand. I'm very much confident that partially or 70% I could make you understand, but I have to take the help of a board, or I have to take the help of a slide or PowerPoint presentation, whatever you say, when I have to teach the slow learners. That is why the concept based learning, that is why the peer learning, that is why, what to say, experiential learning are coming into the context. Had it been 90s, then this would have been prevalent, but this is for them, those who are very much studious, those who are very much careful, those who are following my words impeccably and meticulously. See, I have taken 17 minutes of yours. This is my problem, when I speak I never stop. So thank you very much, student. Again I'm telling you, play safe, make your environment clean, fine. Take care, see you next time. Thank you very much.